Several software packages can assist in calculating conductor ampacity for duct banks with various configurations. These tools are designed for engineers and professionals in the power distribution industry and often require a subscription or purchase. While they may have a learning curve, they can save time and effort in conducting complex calculations. Some examples include SKM Power Tools for Windows, ETAP, Power GMT and T&DWorks, and Right-of-Way Calculator. These software packages typically offer several key features. Firstly, they allow for custom duct bank configurations, enabling the definition of specific arrangements of ducts and conductors. Secondly, they calculate ampacity based on industry standards such as the National Electrical Code, referred to as NEC, the International Electrotechnical Commission, known as IEC, and other relevant standards. Thirdly, they consider various factors that affect ampacity, including temperature, load factor, and thermal resistance of the surrounding soil or concrete. Fourthly, these tools provide detailed reports and documentation of the calculations, which can be helpful for record-keeping and compliance purposes. In addition to these core features, some tools also offer additional capabilities such as voltage drop calculations, fault analysis, and protection coordination. This can provide a more comprehensive analysis of the electrical system. Let's elaborate on some of the key aspects considered in these calculations. Temperature is a critical factor, as the ampacity of a conductor decreases as its temperature increases. The software takes into account the ambient temperature, the conductor's operating temperature, and the thermal resistance of the surrounding materials to determine the conductor's temperature rise and corresponding ampacity. Load factor refers to the average load in the conductor compared to its maximum load. A lower load factor means that the conductor is not constantly carrying its maximum current, which can allow for a higher ampacity rating. Thermal resistance is a measure of how well the material resists the flow of heat. The thermal resistance of the soil or concrete surrounding the duct bank significantly affects the conductor's ability to dissipate heat and maintain a safe operating temperature. The software incorporates these thermal resistance values into the ampacity calculations. When using these software packages, it is crucial to input accurate data for all relevant parameters. This includes the conductor size and type, the duct bank configuration, the ambient temperature, the soil or concrete thermal resistance, and the load factor. Incorrect data can lead to inaccurate ampacity calculations and potentially unsafe operating conditions. To further illustrate the factors affecting ampacity calculations, consider the following. The National Electrical Code, or NEC, provides tables and guidelines for determining the ampacity of conductors in various conditions. These tables typically assume specific ambient temperatures and soil thermal resistivities. When the actual conditions differ from those assumed in the tables, correction factors must be applied. For example, if the ambient temperature is higher than the temperature assumed in the table, the ampacity must be derated to account for the increased temperature. Similarly, if the soil thermal resistivity is higher than the value assumed in the table, the ampacity must be derated to account for the reduced heat dissipation. The software packages mentioned earlier automate these calculations and adjustments, saving time and reducing the risk of errors. They also allow for the analysis of more complex duct bank configurations that are not covered by the standard NEC tables. In addition to the NEC and IEC standards, some software packages also support other regional or international standards. This can be beneficial for projects located in different parts of the world. When selecting a software package, it is essential to consider the specific requirements of the project and the features offered by each tool. Some factors to consider include the complexity of the duct bank configurations, the accuracy and reliability of the calculations, ease of use of the software, and the availability of technical support. It is also important to ensure that the software is regularly updated to reflect the latest industry standards and best practices. While these software packages can greatly simplify duct bank ampacity calculations, it is still essential to have a thorough understanding of the underlying principles and factors involved. A qualified electrical engineer should review the results of the calculations to ensure that they are accurate and consistent with sound engineering practice. Furthermore, the The software should be used as a tool to aid in the design process, not as a substitute for engineering judgment. In addition to ampacity calculations, some software packages also offer other features such as voltage drop calculations and fault analysis. Voltage drop calculations are essential for ensuring that the voltage at the end of a conductor run is within an acceptable limit. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Fault analysis is used to determine the magnitude of fault currents that can occur in the electrical system. This information is essential for selecting appropriate overcurrent protection devices, such as circuit breakers and fuses, to protect the equipment and personnel from the effects of faults. Another important consideration is the long-term performance of the duct bank system. The software can be used to evaluate the impact of changes in load, temperature, or soil conditions on the conductor ampacity. This can help to ensure that the system will continue to operate safely and reliably over its entire lifespan. In summary, software packages are available to calculate conductor ampacity for duct banks with custom configurations. They consider factors such as temperature, load factor, and thermal resistance, and allow for calculations based on the National Electrical Code, the International Electrotechnical Commission, and other standards. These tools provide detailed reports and documentation. Some also offer voltage drop calculations, fault analysis, and protection coordination. It's important to remember that these software packages are tools that assist engineers and professionals in the power distribution industry, and they require a subscription or purchase. Also, it may take time to learn how to use the tool effectively.